IPython notebook. So I'm going to rerun it. So this is an IPython notebook. This is basically a web interface of Python, right? Most of the work basically happens on the cloud. So this is Python on the cloud, and you'll have one of its instance saved on your laptop in the folder which you've already set up, right? So let's say, okay, this is a cell where we are going to type a code. We can even type some text commands, instructions, we will see. So you see this thing here which says code.
Yeah.
So I can convert this even into a markdown. So let's say instead of writing a code, I just want to give some instructions, which is just text based, which is not a code. So I'll say, this is the first Python class, right? And I want to run it like this. So it's going to print out like that. But let's say if I want to type a code, do some computation, and I put it as markdown, it will not give me a computation. But if I convert it into a code, it will run it as a code. You follow this?
Yes.
Now let's say there's one more thing. I want to, let's say, type some code. Doesn't matter what it says right now. Don't bother about that. And I want to save it for later. I don't want it to run. So what I will do it, I will just convert it like this into raw NB convert and then run it. It just saves. It doesn't run it.
Okay.
So let's say along the way, we will need some reference codes, which we don't want to run, but we just want to keep it for reference for later. So you can just convert the cell into raw NB convert. So there are basically three modes we'll use. Use code to write the code, which we'll be using most of the time, markdown, and you will see along the way when I do it. So this is this. Then let's say I want to insert a cell above this. So I can do this. I want to insert a cell below this. I can do this. I want to just remove this. I can just cut it out. And if I want to save this file, just go to this disk icon, floppy icon, and it will save your file automatically to the folder which you have defined. And let's say there is sometime, we can just get into a loop and the process just goes on running and running. And at that time, we just want to stop. What we can do is just interrupt the kernel and it will stop. All right.
Yes.
And if you want to kill the kernel altogether, this is the stop button. Just you can kill it. So these are the cells which you'll be using predominantly.
Okay.
Cool. And at any time, if you don't follow something, just ask me, though I'll keep on prompting you. So now you're good with IPython notebook, right? So we can go ahead.
Yes.
Fair enough. So we'll launch straight away. So now we are in the code cell and we'll begin by, so this is basically a print command. So the structure, the syntax of a print command is in Python is print. Then you have a bracket. Now within that, I'll put quotation marks and I'll just print whatever I want to. So let's say, welcome to the amazing and rocking world of Python. And I run it. So anything you want to run cell, you got to press this icon.
Okay.
All right. Now let's go to some Python operators and do some simple maths. So this I'm just putting as a heading, the Panatha. So what I'm going to do is I'll put it in a markdown mode, not as a code mode. And I want to make it bigger as a heading. So what I'll do is I put like some 3 hash. So you'll see what it does. Now, when I run it in a markdown mode, right, it appears bold and big. If I want to make it even bigger, I remove 1 hash. Okay, so Dipanita, you don't have to bother about taking any of the notes right now, because I just want you to pay attention and follow. You don't even have to code along in the very first class. Whatever I'm going to be teaching you in this session, I will save this entire thing as an HTML file and I'll send it to you. You can use it as a reference and then you can run your own exercises. So in this class, just follow whatever I'm doing. If you have any questions, ask. Don't bother about taking any notes. You'll get all of them with references.
Yes, I've done a bit of Java earlier, but I'm not familiar with the syntax of Python. So like some of the coding bases like loops, if and else statements, I'm familiar with that.
Well, that's good. because loop and if and else statement is probably the raising data of Python. So when we do some very complex iterations in some big files, we use a lot of for loop. So good. And so Python is fairly simple. Most of the syntax is very intuitive. You'll just understand it as simple English.
Okay.
Fair enough. So we're going to do just some very simple things. So there's something called string. String is basically a set of characters. So I'm going to put it in Markdown. See how I'm changing the property of the cells. So this is a string.
Yes.
It's a set of characters. Now what we'll do is let's do some. So within the code cell, the Panata, if I want to, let's say, put a title or a reference, and I don't want it to interfere with the code, what I do is I just do hash. So I'm still in the code cell because I'm going to write a code as well here. But for the code, what am I going to be doing in the code? I'm giving a reference here, but I don't want it to interfere because if I do not do a hash, right, it will throw me an error. So when you just want to comment out something, just press these hash.
Yes.
So now I will do, let's say 2 plus 2. Let's say print 2 plus 2. And I don't even have to say print. I can just do 2 plus 2 and it will say this. I can do 2 into 3. So the star is used for multiplication. And just like we use in Excel, the slash is used for division. Then if you want to take a power off, that's double star. Okay, so that's 2 to the power 3. Now,
Okay. So power is double star.
double star. Yeah. So you go to exponential. So now the power can be used for anything. I can take a higher power or I can even take a lower power. When I take a lower power, I can be computing, let's say, under root or cube root. So let's do that. I want to find the cube root of 8. So what I will do is 8 to the power 1 by 3. Cool?
Yes.
All right. Now do modulus. So modulus basically will return a remainder.
Okay.
And a good practice, Dipanita, is, okay, let me just rename this file. As you make any file, keep on saving. Because at any given point of time, let's say if something happens to your kernel, you lose all your work. Though Python has a checkpoint. You see this here?
Oh, yeah.
You will see that the last time this file was saved was 15 minutes ago. So I want to keep saving my work. You don't want to lose it. And it's a good practice whenever you start writing some complex codes and you want to reference, because don't rely on memory. It's a good programming practice to always keep writing references to the code. Just
Okay.
like I've written here, right? So now I'm going to run it. And I'm doing a hash here. So this will not interfere with my code. Still a code set. So it returns a remainder. Now I can do something called a floor division. That is like these double slashes, 23. And it will, what this does is, so this is a floor division. It rounds off the result to the nearest integer, to the nearest whole number. Now, this double equal to sign is an inequality in Python. So what it is going to do is it will compare the left and the right hand side, and it will give you a Boolean answer, which is either true or false.
Okay.
So it's actually comparing 4, 5. So 4 is equal to 5, answer is no. So it will give you a false. So 6, I'm going to do equal to, I can put an expression also here. What do you think will this return?
This should return for true.
Yes. Now I'll say this is a not equal to sign. Okay, let me comment it out. 6. This is not equal to sign. So again, I'm comparing. 4 not equal to 6 is a true statement. You can do for just about anything else. 6 greater than 4. It is just comparing and it's returning true or false. I can do 3 lesser than or equal to 4. Then what I will do is I will do an absolute of -3. You know the concept of absolute, right? So it will return the absolute. Good to go so far?
Yes.
All right. Let's try some exponential numbers. So when I write function, so Python has a lot of inbuilt software libraries. Since you've done a little bit of Java coding, you'd be aware as to what libraries are. Libraries are basically, let's say I can create a short program to do perform a particular task. So lots of these tasks are already pre-programmed and they are inbuilt into Python as functions. So we can just invoke those functions and make our job simpler. So one of those functions, of which we call software library, is a library called maths. So you understand the concept of software library?
Yeah.
So when we import any inbuilt software library, right, this is basically the syntax. You say import, right, and it will come as bold green, and you do maths. So this is importing library. Importing a library. Okay. Now, this is a software library called maths. Now, within maths, there'll be a lot of functions. So I want to invoke a function called exponential function. So exponential functions, I've invoked a function within maths library called exponential, and I want to take an exponential of 1, which is e to the power 1.
Wait, how does that work?
So this is a software library called maths.
Yes, I got that. But how
Now,
does
one library can have many functions into it. So let's say one function is log, another function is exponential. So, right. So within that library, I'm invoking another function. So it is maths dot, that is a syntax. The library dot function. Okay, let me just. That is a syntax. Okay. Library dot function, and you put the value. So here, what I'm trying to do is I want to take an exponential of 1. So exponential is basically e.
Oh, e to the power 1.
E to the power 1. Now I want to do log. So just remember the syntax, library dot function, and then you have these enclosed brackets. Sorry, this is log. This clear?
Yes.
So we did a power of, so there's another inbuilt function. What we can also do is I can just say power of 2 to the power 3. Or I can say, let's say power of 8 to the power 5. So that's another way. So this becomes your reference. You'll remember what it is. In the syntax, first is a number, second is the power.
Okay.
So that's the syntax, number, power. Now, pretty much like we do in Excel or anywhere, I want to round off a large floating point number, 4, 5, 6, 7, 8. So I will do round off, and I want to define the number of digits that I want after the decimal. Let's say I want 3. So it will round off to 3 decimals. I want only 2, it will round off to only 2 decimals.
Okay.
All right. So there are lots of inbuilt functions. Let's say I take a series of numbers 1, 3, 6, -5, 11, and I want to find the minimums. So this is the syntax. Similarly, I want to do max. And let's say I take the same digits as above. So Devananda, you'll notice one thing, that a lot of these things which I'm now commenting out, they're very, very intuitive and very basic. The reason I
Yes.
do this is because you, as a good programmer, you need to build a habit of referencing out even codes which look very trivial, because it can become a lifetime of work. For example, I want to reference a code which I wrote 8 years back. At 8 years back, when I was actually writing it, it was very, very intuitive to me, but it may not be intuitive to me today. But if I have comments which are telling me what exactly was I doing with that piece of code, right, I
Yeah.
will immediately be able to recall. All right, so that's minimum, maximum. Now we'll import another library called random number library. So there's a library called random. Now within this, I will say, let's say print. Remember the syntax, software library dot function within that. So within random, there's another function also called random. What this will do is it will return what happened. Okay. So the syntax is wrong. So it will throw you an error. So print statement always is within enclosed brackets. Next time I do, it will throw me another random number between 0 and 1. Now, within this, there is another function called rand range. So let's first go to the syntax of this. You define a range. Okay. Start number, end number of the range, and the steps. And this will become clear now. And it will return a random number within this range, which is the start number and end number in these steps. So let's say I take start number as 2, end number as 18, and I want it to go with hops of 3. Let's see what it produces. So this producing in the first instance, giving me the start number. Next, it's giving me 17. Think why it's giving me 17. Because I've defined that the steps should be in 3.
Yeah.
So what are the numbers it can randomly produce? It can only produce one out of the following numbers: 2, then 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14, 14 plus 3, 17.
Okay.
17 is the last number within this range. So you'll always see that any number it will produce will be within between 2 and 18, but it will be 2 plus a multiple of 3.
Okay.
Now let's say if I make it 2, then we'll get all even numbers.
Yeah.
So this thing actually becomes very, very handy, because when we do some advanced computation and modeling, wherein we want to define, let's say, a random phenomena, and we want to take some random numbers to model statistical properties, this comes in very handy.
Okay.
This is
I have
this.
a question. Is 18 the inclusive or exclusive?
Sorry,
Is 18 inclusive or exclusive?
80.
18. The 18, is it inclusive of 18 or
It
exclusive?
is inclusive. The range is inclusive. So let's do a few more times, then we should get 18 also somewhere. So both the start and the end number are inclusive.
Okay.
All right. So now we'll go to something called string formatting. So let's say I will say my name is, and I want to put my name. So I will say, so this is the syntax. Okay, let me first define the syntax and then we'll take an example. So I'm hashing it out and defining the syntax for string formatting in print statement. So it will go something like this within the bracket. Okay. I will write my text. Then this defines string. I will add a string to this. And then again some text. And let's say if I want to put here D, this will be for inserting an integer. And it will become very intuitive to you when we do this. And text, and let's say I want to insert a floating point number also here. So I'm going to do, let's say, round off to 2. So F defines floating point. Now this is the syntax. I'll go to the next line. Now I have to define the parameters for this. So it goes within the quote, and we can have single quote or double quote, it's fine. Let's do a double quote here. And I have completed my statement here. I will end this quote. After this, I will do print and I will put another bracket where I will define these parameters. So the first one, let's say, is a string parameter. So I will define a string parameter. Then I will define there is an integer. Then I will define an integer here. And I will define a floating point. And then I will complete the bracket. Now let's take an example. Let's say my name is, and I'm doing %s, and I study in class, let's say it's going to be an integers, and I'm adding th. And I'm closing the quote and I'm putting a percentage to format this, and I'm putting another bracket wherein I define parameters for this %s and %d for integer. So first name is, let's say, Zara. The second is going to be 10. Let's see what it does. So my name is Zara and I study in class 10. So this way you can create a modular print statement and I can keep changing this. For example, my name is Sam and I study in class 11. Now, there is a simpler way of doing this as well. So where we'll go with the syntax that colon, some text, then you want to put a parameter here. So you just put these parentheses. You want to put another parameter here. You do this. And after this, you do what we call format function. And within this, you define this.
Okay.
Right? And we close it out. So I will do the same thing which we did above. Print. My name is parenthesis and I study in again parenthesis. And format. Okay, I have to define what it is. This is, let's say, name. And this is class. So in this, I can explicitly define name is equal to Zara. And class is equal to 10.
Okay.
Let me, okay, class is already a function, so I'll put the grade here. So you choose, this probably is more intuitive. So let's say I want to make a statement where I want to insert parameters and those parameters can keep changing. So I'll say my name is parenthesis, you define what you want to put here, name, and I study in, put the parameter name, grade, and you do dot format, and you define within the bracket, you know, what are the values for these parameters. So these are the parameters, you define the name of the parameter, name, grade, and then you have to assign a value to these parameters. So let's try one more. Parenthesis within bracket. Okay. Now my name is name. And my percentage for class 10 was, I'll put again parenthesis, my marks. Right? Now I'm going to do format. I will do name. Name is equal to Zara. And marks equal to 99.9. Let's see what happens. Cool.
Yeah.
This is probably more intuitive and simpler. You can just use the format function if this one looks a little complicated. And this will again come in, it's very, very handy when we, for example, build some big programs. And within those programs, we have to print out the results of those programs, even if we are putting it in a loop or in an iteration. And in each iteration, we wanted to print out certain specific values, which will change with each iteration. So we can parameterize the print function in such a way that whatever are the values which are appearing for the specific iteration, it will throw out those values through this formatting statement.
Okay.
All right. Cool. Let me save this. Now let's try to combine some math operator and string. Math operator and string. And let me make it a markdown cell. And say print hello, and I want to add one more. So I want to add some space between hello world. Okay, first let's just do hello plus world. So you see they are sticking together. Now I want to add some space. So I will do print hello plus I will add a space.
Yeah.
So between these two quotation marks, I'm going to add a space. And that's also a character. And then I'll say word. And
I
then
have a question. Why can't we just add a space between like
you
hello?
can do that. Yeah. So I know what you're asking me. You're basically saying, why can't I do this? Right?
Yeah.
Yeah. So this I'm explaining because there'll be many instances wherein you will need to either add space for different reasons. Okay, let me just give you an example. Let's say I want to say print my name, right? Then I'll add another print statement. Print my age. Right? Now I want to add a space in between these two print statements. So what I will do is I will add another print statement and I will just add space. Similarly, out here, right, you can add plus signs and you can add like multiple things. You may need it in many instances, you may not, but in some instances you may. So you can use these mathematical operators as well to concatenate two different strings. Let's say we are assigning see that?
Yeah.
I can add space and then I can say x plus space plus y.
Okay.
And this, now what happens is now this has become my variable. I'll come to what variable is, but this I can make it modular. I can change the value of x, I can change the value of y, but my print statement remains intact. Got it?
Yes.
Okay, now let's go to some assignment operators. So I'm assigning a value of 5 to x. X is a variable. Think of a variable as basically containers in the memory which store certain data values. And then we can play around with those variables and we can perform computational functions or any kind of functions, and we can parameterize. So variable, I'll cover it in a bit more detail, but think of variable basically as containers for storing different data values.
Yeah.
You would have probably already studied in Java, but still.
Yes, I know some of the basics of all of this.
Containers for storing data values. So here, see, there's a code cell. I've hashed it out, so it's still fine. But I'll instead make it a markdown. And then I'll remove the hash.
For Python, do we need to declare the variable type or?
We will come to variable type. It will automatically be declared by certain notations we use. We will come to it.
Okay.
Now, there is a short form. And what this means. This is same as x equal to x plus 5. So I've already defined a value of 5 to x. I'm running it. Now I do this. What should I get it? Okay, let's say.
Is it x plus 5? So it'll be 5 plus 5.
So why did this happen? Because I did it twice. Let's define x again. Right?
Yeah.
Now, what is the value of x?
10.
If I do this again, what should I get?
15 now.
Correct.
Okay.
And likewise, I can do practically anything with this. So this is short form. I can put the computation I want to perform on the left hand side, then equal to, and assign the value what I want to do. So let's say I want to do x equal to x minus 5. What should I get here?
This should be 10 now.
Correct. Okay, I need to print x first. I can even perform a multiplication here. X. What should I get here?
We should get 5. Wait, into.
50. This is star. Star is multiplication.
Yeah, I thought that was a minus for a second.
Okay, so the star is multiplication. This is minus. This is multiplication. This is basically doing x equal to x into that number. So last value of x was 10. So 10 into 5 is 50.
Yeah.
I can do a division. So x, I will say divide equal to 5. What is the last value of x?
That was 50, so it'll be 10.
Correct. Now I can even do a modulus of this. X what should this return?
This should return 2.
What is modulus? Modulus gives the remainder.
Oh, 0 then. 0. Sorry.
Now I'm going to do an exponential. What should this be?
0 because 0 to.
Correct. But let me change the value of x. Now, what do you think this will be?
5 to the power 5.
Yeah. So you got to be a genius to come up with this number. Got it?
Yeah.
All right. Now we have to, let's just go back and understand these two inequalities. Right? So former is used for assigning value to a variable, and latter compares left and right side values to deliver true and false. So this is very important. This equal to sign is used for assigning value to a variable, and when we use these double equal to signs, They are basically an inequality which is doing a comparison of the left and right hand side, and it will return a Boolean answer, true or false.
Okay.
So if that is the case, let me take an expression 6 by 3. And I do, what should this return?
6 by 3 is, this should give false.
Okay, let's make it more interesting. Now we know the print function. I'm going to give multiple expressions. 6 modulus 3, comparing it to equal, and I'm putting an AND function. Have you studied transistors?
Uh, in physics or?
In general, do you know AND and OR operators?
Yeah, I know that.
Okay, but I'm still commenting it out. These are logical. This is a logical AND operator, which returns true when both conditions are true, else false. So what should this return?
This should return true.
So let's do one more. How about this?
This should return false.
Okay. This is a logical OR operator which returns true if either condition is true. So what should be this? True or false?
This one should be true because like the first one is.
Yes. So we're clear about this?
Yeah, this is clear.
So logical and OR operators. So now let's define a variable. Okay, you've understood what a variable is.
Yeah.
It's a data value container. So now I'm going to give one of these expressions and put it in the container. So now I'm calling 6 is equal to this expression. So this expression was, so let's print out C. Fine. If this is C, then there is also something, the reverse of C, which will be not C. What is not C? A not operator converts a true value to false and false to true. Okay. Now we go to something called membership operators. Exists in a specified sequence of numbers or not. So if exists, else false. Okay. Okay. Let's put it in a quote cell only. And what I will do here is, so you understood this? Here we'll check whether a given variable is in a sequence of numbers. So let's say I want to check print 4 in, and I'm defining a list. And what is the list? We will come to that in some time. But let's take a sequence of numbers. And the sequence of numbers 3, 5, 6. It will give me a Boolean answer, true or false.
This one will be false because there's no 4.
Yes. Print. Now I will do 4 in a sequence of numbers 7, 6, 5, 4. That's true.
So this checks if the there's like the number in the list.
Yes.
Or
And that
array.
is why. So if you exactly what you said. So a lot of this is very intuitive. Python is very intuitive, just like English. So you think about it. What it is saying is, hey, is 4 in this sequence of numbers? True, false. 4 in this sequence of numbers? True or false? So it's checking whether this variable has a membership in the sequence of numbers.
Okay.
I can do the reverse of this also. 4 not in 7, 6, 5, 3. What should this be?
False. Oh, not in true. True.
And this, what should this be?
One is false.
All right. So membership operators. Let's go to replace function. There's a function called replace. So what will be its syntax? Let's define its syntax. Syntax will be, you take a string, replace that string, take a old value, old character within the string, replace it with the new character, and you can define the number of occurrences. So I'll define a string. String 1 is equal to, let's say, meta. Okay. Let's say print string 1. So that is string 1. Now I want to replace something in string 1. So let's now print string 1 dot replace. And I want to replace capital M with small m. And if I'm not defining the number of occurrences where I want this replacement, by default, it will replace all the capital M. So let's print this and see what happens. Got it?
Yeah.
But now I define the number of occurrences. I want only one occurrence. See that?
Okay.
I can make it 2. Yeah, see that?
Yeah.
I can make it 0. So that's how you can replace characters within a string.
Yes, sir.
Okay, now let us do a little bit of playing around with certain characters. So I will define an expression which is, let's say, 5.5 plus 6.6 plus 7 plus 8.8. And I want to print out what is x. So that's the value of x, right? Now I want to, let's say, divide x by 4 because there are 4 numbers here. So that will give me the mean. Okay. But what if we had a much bigger list? Now let's define x as a list. So I'll come to the list data type, but right now just think of it as a sequence of numbers. So let's define multiple numbers here. Let's say I define number 5.5, one number, I define 3, I define 6.6, 3, 2, 1, then 5 again, then 6 again, then 11. Now, what I can do is I want to know the sum of this. So now this is a variable, right? This variable is capturing a particular data type. Now I want to know what is the sum of this variable, which will compute all these values within this variable. Okay.
Yes.
Now to calculate the mean, I also want to know how many different elements are there in this sequence of numbers. So what will I do?
It's just sum divided by the number of numbers.
Yeah. So how do we compute? So the way we do it is let's define another variable which will count the total number of elements in X. So when we do this is the function len. It computes the length of this variable. Length, it will compute, returns the number of elements in the data type. All right. So what should be the value of this total? There are how many numbers? 3, 4, 5, 6, 9 numbers. Okay. Now compute. Sorry, you're saying something?
No, I'm just saying, yeah, we then from this we can just
Compute the mean, right?
yeah.
Now I'm going to compute the mean. So mean is going to be sum of x divided by total. Got it?
Yes.
Let's come to Python variables, even though I told you. But let's drill down a bit more into Python variables. So we already said that, okay, let's put it here itself. They are some reserved memory locations used to store data values. So let's define multiple things. So this is an integer. Now D is equal to, so if I want to define number as floating point, all I need to do is put a dot. I can put dot 0, 0 or 0, 0, 1, whatever, if there are more, but if it's only 0, I leave it at dot. So this converts an integer into a floating point, and we will see just now. And I'm defining a third variable, which is a string. Okay. I want to print all of these. So C, D. So even if I don't put a print statement, whatever is the last line out here, it will just return the values within that variable. Got it?
Okay, wait, but we didn't write print, so
Yeah. So the last line in the code cell will return. So you'll see out
yeah,
is the output. So the last line, whatever is the last line in your code cell, it will be returned as an output.
okay.
Do a print here. So this is printing me. This is not the output. I'm explicitly asking it to print out. If I
Oh,
leave it, then whatever is the last line of code, whatever is the value which is precedent within that, it will automatically return as an output of the cell. So these are the inputs. Now see, this is showing explicitly the output.
okay.
But let's say if after this I define another variable, let's say CDE is equal to, let's say 21.2. Will I get CDS now? No, because it's not the last line of the code. Then nothing will come. So only the last line comes out as an output. But to play safe, you can always use print statement very generously. In Python, keep using print statement because even when you're defining a bigger function, in between when you keep printing out, then you know that your function is working at every single step. So you can put checks. And the way to do check is by just printing out whatever is the output at an intermediate step.
Okay.
So we can print out these variables together and we can even print them out individually.
Oh, so if we just type CDS as the last line, it will just print the last like output.
Yes, yes, that's the last line of the code. So it will just return. So it's not printing out, it's returning.
Okay.
There is a difference between printing out and return. And you will come to this concept, which is called return, which is returning the value which is inside a particular variable when we come to defining functions within Python. So this is output. And I showed you that if I put a print here, it will not show me an output. Then I'm specifically printing out these variables. And there is a simpler way of defining these variables. Right now, what has happened is I've used 3 lines of code to define 3 variables. I can do them in one single line, C, D, S, and I can give them individual values. This is better?
Yeah.
Okay. And you know that we can even define, all kinds of values to a variable. So let's say here this is 9 modulus 4. So you see the difference here? So this, right now we have defined this value into this variable, right? So this value is 1. It's gone into X. So the value of X is now this. Now
Okay.
let's define 2 different variables like we did earlier as, let's say, 7 and 6. And I can just, what should it give me? First, will it return a value or it will not return a value?
It will return a value.
You're right. Okay. What will happen now? It will throw an error. Why? Because we have not defined Z.
Not defined.
But let's say if we define Z is equal to 9. Now we won't get anything because not the last line of the code.
Okay.
But now we define Z, and let's say we define a new variable and we use X and Y. So we say Z is equal to X to the power 2, X square
Yeah.
plus 3 into Y. And now we want to print out Z, or rather we want to return Z. Now let's delete a variable. You can mark down. What I will have to do, okay, I will again say print Z. Then I will say, if I want to delete Z, I will simply say del Z, and then I will again print Z.
Does this just like delete the variables here or what?
Yeah, it deletes the variable. So the first print statement is giving me the value in Z, which was originally 67. Then I deleted Z. Then it's saying Z is not defined.
Okay.
So take a few more. Let's say I'm defining a variable called name, and we say Sam. Okay, I will say print name. But now I will say delete the variable name. And I will again say, okay, print the variable name. Got this?
Yeah.
So now you have to keep in mind there are some valid and there are some invalid variable names. What did I do here? Why is it? So let's say counter is equal to 10. This is a valid variable. I can even put, let's say, underscore counter without any space equal to, let's say, 20. I can say name equal to Sam. I can say there is name 2 equal to, let's say, Zara. I can say age equal to 21. And these are all valid. So I can just return this, counter underscore counter name into an age. But what if I change this? And if I make it instead hyphen? This is not a valid variable. It will throw me an error.
Okay, so we can't put symbols in the.
Yeah, yes, you're right. You also can't put these symbols. I can't put a dollar sign, right? I also can't put a numerical value here. It's invalid. But I can put the numerical value on the right hand side.
Oh, okay.
Counter 1. Counter 1. This is counter 2. This is name 1. That is valid.
Okay.
So let me give you some example of invalid variable names. Let's say one counter is an invalid variable name, then dollar underscore, that's invalid. To name, I'm putting a number ahead, it's invalid. Or I'm putting, let's say, Sam hyphen salary, this is invalid. So this will be a reference. Now, if I want to put this in a reference, what should I do? I can do two things out here. This is not a line of code. So I can even put it as markdown. But the markdown is not giving it to me in a row manner. So I will convert it into raw NB. Right? And it stays with you as a reference. So now you'll know, okay, let's put some handy points. Don't use numbers, don't use at start, numbers, notations, at start of variable name. Numbers, notations, yeah, numbers, notations. Then also don't use hyphen. Is that the spelling of hyphen? No.
Yeah.
Use hyphen. So a good practice is always just use these text-based names like x equal to something or counter equal to something, name equal to something, age is equal to something. And the name of the variable should be very intuitive, because when you're writing a function, that variable name should be very intuitive. For example, if I am computing, let's say, the class scores, right? And I'm creating a variable which will contain the class scores. So I can't just say x equal to something, because it's not very intuitive, even though it will be technically valid. But to make it intuitive, you write the variable name as class underscore names, class underscore scores. For example, this is a valid variable, class underscore scores, and I can store those values. Let's say 81, 83, 85. Got it?
Yeah.
Okay. Now we will come to Python data types. So there are 5 data types in Python. Okay, and they are numeric, dictionary, which is also referred to as dict, Boolean, set, and sequences. These are 5 data types, and you will encounter all of them. Now, within numeric, you have float, you have integer, and you have complex numbers. And within sequence, dictionary is dictionary. There's only one data type, and then you can have 3 kinds of sequences. Strings, which we already saw, list, which we will now cover, and tuples. And I'm going to convert it into raw MB format so that it stays. This clear?
Yeah.
So this gives you a structure as to how many data types we have and what is contained and what are the various types of sub data types within those data types. Okay. Let's go with numeric. We've already been covering, but let's take it once more. Let's say I define an integer equal to 90, and I define a floating point equal to 90.3, right? And while we are not going to be using it, but you may, for example, if you ever do computational physics, you may need some complex numbers. So the expression will be something like this: 300 plus, let's say, 10j. So this is real part and imaginary part. So you know the concept of real and imaginary numbers?
Yeah, I've taken all three levels of calculus.
Okay. So now okay. So I've defined a numeric data type. Now I want to check what is the type of my variable. So what I do is, the way to check type is I check type. I type I. Let's go line by type of my variable I, type of my variable F, and type of my variable M. Okay. So here I want to know the data type of these variables. So the first type is integer, second type is float, third type is a complex number. Yeah.
Yeah.
Okay. I want to create a new I variable where I want to just convert the floating point j. So I will do convert the f variable, which was a floating point variable, into an integer. And I will check what is its type now. Correct?
Yeah.
And I can do the reverse as well. I can do a new f, which will do a float of the integer variable I. So, okay. Now let's take strings.
If I type print to this command if I say print new I, will it give the same result?
Absolutely the same result. And as she asked earlier, the difference is right now you see it is giving an output because I did not print it out. So it is returning whatever is the value in the last line of the code cell. If I do a print, it will not give me an output, but it will give me the same result, but not as an output. So it was telling you what is the data type. That's class integer, class float. Now I'm taking a string expression. Okay, let's come to some string data types. Let's give it some expression. I love, let's say, India very much. I'm going to print this out. So far, it's simple. This is exactly what we did.
Yeah.
Now I want to index it. So let's see how does the indexing work here. Let me make it a mantra. Indexing of values in Python. It starts from 0. And from -1 from left to right, and it will become clear as we do it. So now if I want to slice this string, so this is string variable. I want to pick its very first character. So the indexing begins from 0. So I will do a square bracket and I will do 0. Is this clear?
Yeah.
So what should I get here? If I do string 1 0.
It should give the first one, right? I.
Okay, fine. What should I get if I do string 1 1?
Will it give the space between I and la?
Very good, very good. Exactly. So space is also an index.
Yeah.
Okay. So if you understand the concept of index, then I is 0, space is 1, L is 2, this O is 3, this is 4, this is 5, space is 6, I is 7. So let's do 7. Correct? Did you get this?
Yeah.
Okay, let's make it a bit more interesting now. Print string 1 1 2. What will this do? What will this return?
From 1 till the end of the string?
Yeah, so from the index value 1 till the end of the string. Because I've done a 1 colon, so here I was only picking out one single specific character, but here I'm doing 1 colon, which means 1 onwards. Let me write that. Index value onwards till first index value till second index value till second index value. So it takes right from the first index value, which is space, all the way till the end of the string. What if I were to do this? Print string 1 1, but now I'm giving a second index value. If I leave it blank, it will by default take it to the end of the string. But let's say now I want to give it till 5. It will slice the string from first character, and the second character is not included. It will be 5 minus 1.
Okay, so it's 5 inclusive. But
5 exclusive. Okay.
exclusive.
Slices the string from first index value till second value minus 1. Here I should just say first index value till So just remember this. This is in Python. While I'm saying I want it to index from 1 to 5, so 1 is inclusive, slices from first index value included till second index value minus 1.
Okay.
So now tell me, first is space, second is L,
Yeah.
third is O, fourth is V, and fifth is E. Do you think E will come? No, because it excluded that.
Wait, it includes.
The first index value and excludes the second index value. So it will take only up to the second index value minus 1. So here
Okay.
we said 5, so it will become from 1 is
One,
to.
two, four. Like 1, 2, 3, 4 index values.
So okay, it will become more clear if I print out the string above this. Print string 1. Okay. So this is space, this is index 1, this is 2, this is 3, this is 4.
Okay.
5. So 5 is excluded. So it will print up to 4.
Okay.
Got it?
Yeah. So it just repeats the.
Yes, it does. Now I want to add something to string 1. Print string 1. You had asked me earlier, why do we put a mathematical notation? Why can't we print out? See, here's an example. I want to add another word to the earlier string. But this looks very tacky. So what will I do? I will add a space here. And then I will do. Got it?
Yeah.
Now we want to split a string. So it's a good habit to keep printing out whatever variable you're using, because in computing other operation on that variable earlier in your code, that variable might have got modified. So what is the value stored in the variable currently? It's always good to print out and check. Okay, so fine. This is what string variable 1 looks like, str1 looks like, right? And whereas the original str1 did not have much. Okay, no, it did have much. So it is the original one. And this is something we just added. So this is what we are printing out. Now we want to split this. So what we will do is str1 dot simply split. There is a function called split. What will it do? Now it has split it into different values which are contained in this. So I is different. And when I do this, right, I can even pick out those specific values by index because they are now all split. So if I do index 2, what should I get?
I'm not sure. Will it just split it into.
So see, earlier when it is a string,
Yeah.
right, it is going by each and every character. When I do a split, it has split by these individual words. So now, and it has created a list element within square bracket, and there are 5 elements. So the elements are separated by comma. So this is element 1, index 1, sorry, index 0, index 1, third element, fourth element, fifth element. 0
Yeah.
index, 1 index, 2 index, 3 index, 4 index.
Okay.
Okay, so okay, let's give it assign a value x equal to this. I want to print X. Okay, X is equal to, okay. It won't assign it to X. Okay, I'm just splitting the string here. So now I'm splitting the string and I want to index the second value. Or I want to index the third value. Or if I want to index the last value, the notation is -1. Second last value, -2.
Okay, I think I get it now.
So where I gave you the second value. Now I should add one more line here. Reverse indexing is from right to left and starts from -1, then -2 onwards. Got it?
Yes.
This is a reverse indexing. This is -1, this is -2, this is -3. So -3 will yield the same result that +2 yielded here. Because I'm counting now from the right. Okay, now let's take two strings. Let's go to list variable, which we've been talking about. So what is a Python list? Python, let's say, Python list contains items separated by commas and enclosed within square brackets.
Yes, it's like an array, right?
Sorry?
It's an array, right?
It is a
Array.
so list and arrays are pretty much very similar, but there is a difference.
Okay.
Like in array, for example, if you were to ever do, let's say, matrix, you understand matrix? In high school maths, we did matrix.
Yeah, I'm taking linear algebra.
Yeah, so you've done linear. So if you do matrix, you can do a transpose of matrix, right?
Yeah.
For that, we use arrays.
Yeah.
For that, we don't use list. There is some difference.
So arrays is more like matrix and numerical values and list.
Arrays are matrix.
Okay.
So within an array, we can create a matrix. We can create multiple dimensions. So even within this, we can create multiple dimensions. But let me give you a quick reference. For example, if you were to ever do, let's say, a visual data science, wherein you have to process input images. So the value of images are in pixels, and there are many pixels. Let's say there are 1 million pixels in one particular image, right? That will go, and that is multi-dimensional. That will go into an array. And then doing some complex operation, you will do matrix multiplication as well. So you can do matrix 1, then you can multiply with transpose of matrix 1 or matrix 2 or whatever.
Yeah.
So this is what a list is. It's basically a data type which is contained within square brackets, and it contains items separated by commas. So this is a list.
Okay.
Right. If we were to put another one, and I say, what is the data type of string 1? I will put type. What is the type of string 1? And what is the data type of string 1 dot split, after I do split. So the data type, after I do a split, the data type changes. First is a string. When I split this, it became a list. And it has 5 different items separated by commas.
Okay.
Now let's take two lists. Okay, and we'll define another list. List 2 is equal to, let's say, duck. Okay. And I want to index the list. Pretty much the same way as we did earlier. List 1, and I want to index the second one. Then I go to list 2. I want to index third 2. Sorry, I want to index. So when I do a colon here and I do second, then it basically means everything from the start up to the second value, where second value will not be included.
Okay.
So before I run this, tell me what will I get as a result of list 1 second index?
List 1 second index, we'll get duck, like we'll get the entire thing because it's until the wait, we'll only get duck.
No, I'm talking about first line.
Oh,
List
just the
1
second
index.
index, 78. Just 78.
2.
Yeah. Wait, 1 second, sorry.
Oh.
86.
Correct. And the second one, what will we get? From the start up
Till
to
the
2,
second,
where 2 is
duck
not included.
get duck and 66.
Why did we get this error? List 2 is not defined. Oh. Okay.
Yeah.
Now there is something called joining these two lists. I can join multiple ways, but one of the ways is called concatenation, which is simply I'll do list 1 plus list 2. What I'm doing is I'm concatenating the two lists. And I can make this as list 3. And this is clear.
It basically adds the two lists, right?
It's basically, okay, I won't call it add. It's joining the two lists. Add is a mathematical operation which will happen on numerical numbers or numerical data type. Here we have two different data types, right? This can contain multiple data types. So there is a string variable, which is a string data type. These are numerical data types. So it is joining. So it will add all of these elements, also include this in the combined list.
I have one question on this. If there are common elements on both, say there's a 66 in both, say list 1 and list 2, will it give it twice?
Let's see what happens. Did you get your answer?
Yeah.
Just
Yeah.
print both of them out.
Okay, now we can slice the list by starting index and hops. So the syntax pretty much will be start index and then hops. The syntax will be colon.
Yeah.
Let's try this. So that is the list tree we have currently. Now we will add print this tree 1 : with 2 hops. So before I print this out, do you want to take a guess at what we'll get as a result of the second expression?
Is it including 2 then?
So this is hops. So don't confuse with single colon. If we do single colon, then it goes from starting index to the ending index.
Yeah.
Now, when we put double colon, it is defining hops. So starting with index value 1, sorry, what's wrong here? Starting with the first index value,
Till
produce everything in hops of 2.
so like 78, then Dhruv, then 66.
Excellent. Okay, now let's do indexing. Negative index, which we covered earlier. I'm going to tell me what will we get if we do this, and if we do print list 3, and if we do what will we get if we do list 3 index -2?
That means the third last till the second, till the
So how does the reverse indexing begin? From -1?
-1.
Okay, so what is the -1 element?
That would be the second last, right?
No, the reverse indexing begins, negative indexing begins
Okay.
from -1. The positive indexing begins from 0. The negative indexing begins from -1.
Okay.
First element to the right will be -1 index.
That
the-
means 12.
And what will
That's
be -2?
66.
Okay. Now tell me for the second expression, if you understand this.
For the second, it will be from the third last to the last, like duck to 12.
Okay, which is -3.
-3 would be duck.
Okay, and up to -1.
Yeah.
So -1 is 12.
Yes. And so it'll just be duck and 66, right?
Why am I getting an error here? Print 3. Okay. What is this? Okay. List 3. Exactly.
Okay.
Because -1 is not included.
Yeah.
And if I remove -1 and I do -3 till the end, then
It'll go until like 12, duck 66 and 12.
so now let's try to replace values in the list. Let's make a new list. It's too much of old list. Data 66. So there are multiple data types in this list, as you can see. Okay.
Yeah.
I'm going to print list 1. Then I want to change the. Okay, no. So before that, let's do the second index of this list, and then let's print this first. This clear?
Yeah.
Now I want to replace the second index. So it's very straightforward. I'll take the second index and assign it a new value. And now I want to print list 1, index 2. Got it?
Yeah.
And now I want to print list 1. So it's the original list, but the number 12 or the index value 12 is now replaced by the value 50. I've assigned a new value to the value which was at index 2.
Okay.
Just like we delete a variable, let's try to delete a list. Before that, let's print out list 1 again. Did you understand this?
Yes.
Okay. Okay. Now I'm going to add one more cell below this. And let's take another function. There's a function called pop, which removes the last object. But the problem is we don't have a list 1. Okay, fine. Let's do another list 1. And start this one. So list 1 pops out the last object.
Okay.
So I'm going to print list 1 pop. No, there is something not right about this. Okay, this is the list 1. Then I do list 1 dot pop. And then I do this. Got it? So it pops out Zara.
Okay.
But I want to now remove a specific element, not just by default the last one. So I will use a remove function. Okay.
Yeah.
I specifically wanted to remove an object, and I've specified which object I want to remove.
Okay.
I already told you, but let me just write down how do we length of a list.
I just have one question on the pop. This is the syntax list 1 dot pop bracket close. That's the syntax.
You define the list name. Okay, where is pop? That's a syntax. Whatever is the list name, dot pop. it will automatically remove the last object in that list.
Okay.
And it can be any list. It can be list 1, 2, X, Y, Z, whatever is the name of your list.
Okay.
Okay. It tells
Yeah.
the number of elements within the list. So let's see if I have anything left of list. Oh, I do. Yes. So length of list 1 will give me how many elements do we have in this. Clear so far?
Yes.
So, okay, that's it for now.
Okay.
Have you understood everything?
Yeah.
So what I'm going to do is I will download it as an HTML file.
Yeah.
I will share it with you. Please keep checking your email because like I sent you a prelude email as well. There are important instructions which I want you to come prepared with. So I'm going to share with you this HTML file. What you should do from your end
Yes.
is that even if it looks very mechanical, whatever is there, right?
Yeah.
Type out in your Jupyter notebook and run it and play around with it.
Okay.
When you do that, you will get a practice. You will even get a look and feel of the Jupyter notebook, how the various things work. Sometimes you'll get an error and you realize you made a typing mistake. So you will get used to that. But most importantly, you'll start building a muscle memory.
Okay.
Okay. So let's go through this entire notebook and I want you to run each and every line of code. And don't copy and paste from HTML. Though it's possible that you can, copy like this and you can do a copy and you can probably paste it in your code cell and you can run it. Don't do that. Explicitly type
Yes.
and run it. And you can change. For example, you can change the string to something else and see. If you get an error, try to figure out why you got an error. Right now, even if you were to just probably run all of these codes manually yourself, that will give you a lot of practice.
Yes.
Good enough?
Yes.
So I'll see you tomorrow then,
Yes, at 10 a.m., right?
9:30.
Okay,
Is it
9:30.
10 or it's 9:30? I think it's 9:30.
It's 9:30.
Yeah, it's 9:30.
Okay, 9:30. Yes.
Okay.
Yes, thank you.
Okay. Bye-bye.
Bye. Thank you.